Welcome everybody once again. So this is our 10th class for module 4. So as we have discussed in our first class of module 1, this module 4 consists of two parts. The first part was about open channel flow and the second part is about notches and weirs. So first part is over. So you can expect one question from open channel flow, another question from notches and weirs. So in open channel flow, we saw how to find the discharge using Chassis formula. Then we saw the empirical formulas, Cutter's formula and Manning's formula to determine Chassis constant. Then we saw a few problems related to these concepts by applying the Chassis formula and empirical formulas. After that, we saw most economical channel sections. We saw three channel sections, that is trapezoidal channel section, rectangular channel sections and circular channel sections. And we saw the conditions and we solved a few problems related to that. After that, we saw what is conveyance and what is section factor. So from today onwards, 3 or 4 classes, we are going to study the next part of our module 4. The second half of our module 4 is about notches and weirs. See, this notches and weirs comes together because both are used for measuring the rate of flow. So, and another reason both comes together is that the formula remains the same for notches and weirs. Okay, so we will see what is notches and weirs. Already we have seen some measuring instruments like a pitot tube, then venturi meter, orifice meter, orifice, etc. Now we are studying notches and weirs. Now, first of all, see, you can see here the diagram. This is called notch, rectangular notch. So above this, the water flows. This is a rectangular notch. And this is a rectangular weir. This is a rectangular weir, right? So notch and weir. See, there is a difference between notch and weir. We will see that. So first of all, see, both are used for measuring the rate of flow. See, above this, the water is flowing above the notch. Okay, here also the water is flowing above the weir. Now, what is the difference? Let us see what is notch. So notch is a device used for measuring the rate of flow of a liquid through a small channel or a tank. So you will have a small channel or a tank, and notch is used for measuring the rate of flow through a small channel or a tank. You can see here, right? Now, it is an opening. Again, the notch can also be defined as an opening in the side of a tank or a small channel in such a way that the liquid surface in the tank or channel is below the top edge of the opening. Okay. So there is an opening. So this opening helps for the flow of water. Similarly, you can see a weir. A weir is a concrete or masonry structure. So it is a large structure. See, if it is made of concrete or masonry, then automatically we can understand that it is a large structure, right? So a concrete weir is that is the difference between weir and notches. Weir is a small, notches is a small, weir is a large size. Notch is of smaller size. So weir is a concrete or masonry structure placed in an open channel over which the flow occurs. So this weir, this is a rectangular weir placed on the open channel. So over which the water flows. So rectangular notch is placed on a small channel or a tank. Weir is placed, not only rectangular notch, notches are placed on a small tank or a small channel. Weir is placed in an open channel. Now it is generally in the form of a vertical wall with a sharp edge at the top running all the way across the open channel. So if your open channel is like this will be placed, this weir will be placed at some cross section running all the way across the open channel, okay, in this direction, and it will have a sharp edge at the top. That is the difference between notch and weir. Now, see, another difference is notch is of smaller size, whereas weir is of bigger size. Notch generally made of a metallic plate, weir it is generally made of concrete or masonry structure. Okay, now you can see rectangular notch. Normally this will be made of a metallic plate. Weir will be made of concrete or masonry structure. And you can see here, this is a section at crest. Now we will see what is crest and what is nape. So first of all, what is nape or no, not nape, it is nape. Nape or vein. V-E-I-N, vein. So it is nothing but the sheet of water flowing through a notch or over a weir. See, that means the water flowing over the notch or a weir. So this is called nape. See, sheet of water. This sheet of water flowing over the notch or the weir is called a nape. So this is called nape. So here over the weir, this is called nape. This sheet of water is called nape or vein. Now, crest or sill. You know, sill always forms the bottom surface, bottom part. Okay, so here also crest or sill, it is the bottom edge of the notch or a top of a weir over which the water flows. So bottom edge of the notch or top of a weir. Okay, so this is a tank. So you will have an opening in the tank. Okay, you will have an opening in a tank. Now, see this bottom part of the notch. This is bottom part of the notch. You will call it as crest or sill. Here, this is a weir. This is called weir. So top of the weir. So this is top of the weir is called crest or sill. Okay. Now, let us see the classification of notches and weirs. So, classification of notches and weirs. First of all, notches. Notches are classified into two types. First is based on the shape of the opening. Second type is based on the effect of the sides on the nape. So, based on the shape of the opening, the notches are classified as rectangular notch, triangular notch, trapezoidal notch and stepped notch. Depending upon the effect of the sides of the nape, notches are classified as notches with end contraction and notches without end contraction or suppressed notch. Now, the weirs are classified. First classification is based on the shape of the opening. As the notches, weirs are also classified into rectangular weir, triangular weir and trapezoidal weir. And one type of trapezoidal weir is known as Sill weir. So we will see what is a Sill weir, what is the condition in the coming classes. Okay. According to the shape of the crest. So you know crest or sill. crest or sill. Okay. So weir, the top portion of the weir is called crest or sill. So based on the shape of the crest or sill, it is classified into sharp crested weir, broad crested weir, narrow crested weir and ogee shaped weir. We will see these things in detail in the coming classes. Third classification is according to the effect of sides on the emerging nape. So weir with end contraction and weir without end contraction. Now, we will move on to the rectangular weir or rectangular notches. Okay. So discharge over a rectangular notch or rectangular weir. So only for this case we will go for a small derivation. Remaining cases we will see just what is the formula and the important things. Okay. Now, discharge over a rectangular notch or weir. Consider a rectangular notch or weir provided in a channel carrying water as shown in the figure. See this. You can consider this rectangular notch or rectangular weir. For both these, see notch or the weir section. If you take a section, the section will be rectangular section. Section at the crest will be rectangle, right? So now you are considering, so that is why it is called a rectangular notch or rectangular weir. Now you are defining two variables. H be the head of water over the crest and L is the length of the notch or weir. So we will define H and L. Okay. So this is H. H is nothing but the head of water over the crest. So this distance is H. Here this distance is H. And L you can mark it in the section length of the notch or weir. Now consider an elementary horizontal stripe of water of thickness dH and length L at a depth h from the free surface of water. So from the free surface of water, free surface is this, right? This is free surface of water, free water surface. So from the free water surface at a distance of h, consider a small stripe of thickness dH. Okay. Now, so thickness of the stripe is dH, length is L and it is at a depth h from the free water surface. Now, the area of the stripe you can take, see area of this stripe is L into dH. So area of stripe is equal to L into dH. See, we know the theoretical velocity we have already studied in the flow through pipes. We have studied what is the theoretical velocity of water flowing through a stripe. So theoretical velocity of water flowing through the stripe will be equal to square root of 2GH. So the discharge through the smaller area or through the smaller stripe, you can take it as dq. This is the smaller discharge, that is discharge through the stripe. So dq is equal to, we know, coefficient of discharge into area of stripe multiplied by theoretical velocity. So that is equal to CD into area is L into DH. Theoretical velocity is square root of 2GH. CD is the coefficient of discharge. So for finding the total discharge, you can integrate the smaller discharge. See, this is the smaller discharge through the stripe DH, but this total height of water is H. Total height of head of water over the notch is H. Over the notch or weir is H, right? So you can integrate from 0 to H. So integrating from 0 to H, you get, integrating from 0 to H, you can integrate dq. So you get integration of 0 to H, CD into L into square root of 2GH into DH. So you can take, see, the variation is with respect to the head H, right? So CD is constant, the length is constant, square root of 2G is constant. So 0 to H, root H into DH. So we get CD into L into root of 2G into, so this is H raised to 1 by 2. So integrating H raised to 1 by 2, we get H raised to 1 by 2 plus 1 by 1 by 2 plus 1, right? So we get H raised to 1 by 2 plus 1 by 1 by 2 plus 1 from 0 to H. So H is varying from 0 to H. So what you get is 2 by 3 CD L into root of 2G into H raised to 3 by 2. So this is the formula for discharge for a rectangular, if the notch or weir is of rectangular section. For a rectangular notch or for rectangular weir, the formula is Q is equal to 2 by 3 CD L into root of 2G into H raised to 3 by 2. Very important. CD is the coefficient of discharge, L is the length of the notch or weir, G is acceleration due to gravity, H is the head of water over the notch or over the weir. Okay. So now we will move on to the problems related to this, rectangular notches and weirs. So the first problem is, see, it is very simple, okay? You can solve it of your own if you know the formula. Just what you need to know is simply the formula. So find the discharge of water flowing over a rectangular notch of 2 meter length. So L is given as 2 meter. When the constant head over the notch is 300 mm. That means your head H is equal to 300 mm, that is equal to 0.3 meter. Take CD is equal to 0.60. So we know this is a rectangular notch, right? Rectangular notch. So for a rectangular notch, we know the discharge Q is equal to 2 by 3 CD into L into root of 2G into H raised to 3 by 2. So Q is equal to 2 by 3 into CD is 0.6. Length L is 2 meter into square root of 2 into 9.81 into H is 0.3, 0.3 raised to 3 by 2. So we get Q is equal to 0.582 meter cube per second. That's all. Second problem. This problem is also very simple problem. Determine the height of rectangular weir. So we need to find height of the weir, right? So height of weir is asked. So you can draw a weir here. Okay. So normally weir is of a concrete structure. Constructed across a large channel, right? So water flows over the weir. So we know H is this, right? The head of water is H. So this is the bottom of the weir, right? So we will take the bottom of the weir as H1. That is the distance from the bottom of the weir to the free water surface is H1. And the height of the rectangular weir, we will consider it as H2. H is the head of water. So we need to find height of the weir. That means we need to find what is H2. So what else is given? So determine the height of a rectangular weir of length 6 meter. So length is given as a 6 meter to be built across a rectangular channel. So channel is a rectangular channel. The maximum depth of water on the upstream side of the weir is 1.8 meter. See, maximum depth of water on the upstream side of the weir. So this is weir, right? This is weir. So water is flowing, the direction of flow of water is like this, from this side to this side. So this side of the weir is called upstream side. Okay. So this side is called upstream side and this is called downstream side of the weir. For the weir, this is the upstream side, this is the downstream side because flow of water is like this. So it is given the maximum depth of water on the upstream side of the weir is 1.8 meter. That means H1, maximum depth of water on the upstream side. H1 is 1.8 meter. H1 is equal to 1.8 meter. Also, the discharge is given as 2000 liters per second. So, divided by 1000, we get 2 meter cube per second. Also, coefficient of discharge is given as 0.6. So, how will we solve the problem? See, now H1 is known. H1 is known. Discharge is known. By using the formula for discharge, we will find H. Then, we will find H2 is equal to H1 minus H. So, for a rectangular weir, we know the formula Q is equal to 2 by 3 CD into L into root of 2G H raised to 3 by 2. So Q is given as 2 meter cube per second is equal to 2 by 3. CD is given as 0.6. L is 6 meter into square root of 2 into G is 9.81 into H raised to 3 by 2. The only unknown is H, from which we will get H is equal to 0.328 meter. Now the height of weir, right? So height of the weir is equal to H1 minus H. We get H1 is 1.8. Height of the weir is H2, right? So H2 is equal to 1.8 minus H is 0.328. We get height of the weir H2 is equal to 1.472 meter. We will move on to the last problem of today's class, third problem. So the head of water over a rectangular notch is 90 centimeter. So H is given as 90 centimeter or 0.9 meter. The discharge is 300 liters per second divided by 1000, we get 0.3 meter cube per second. Find the length of the notch. You are asked to find L if CD is equal to 0.62. So direct problem, substitute the formula. Q is equal to 2 by 3 CD L into root of 2G H raised to 3 by 2. Q is known, CD is known, G is known, H is known. The only unknown is L. Substitute, you will get L is equal to 19.2 centimeter. Okay. So that's all for today. The next class we will start with triangular notches. So next class we will see what is triangular notch, rectangular notch and stepped notches and weirs. Thank you for today. Thank you for listening.